Howdy, my name is Alexander Bowie. I'm a sophomore engineering major here at Texas A&M.
Howdy, my name is Abraham, and I'm also a sophomore in computer engineering.
Howdy, my name is Jaden, and I'm the third sophomore in computer engineering on this team.
And we are proud to present Makoto, our solution to the Hitachi document classifier track at TAMU Datathon. And our name is Makoto, which means sincerity in Japanese. So first, I'd like to walk you through our dashboard right here, which shows you some quick information about the documents, the recommendations, some quick actions, and some recent documents right here. So now let's go over to the upload page, where I can upload a document that will get processed. So I can insert this government documents PDF, and this will begin uploading. So this will begin uploading in the background while I go and look at Reviewer, which actually holds all of the actual classification information. Right, so now you can see in here we have all of the test cases already processed. So now we can look through each and every one. So the first test case is test case 1, which is the public marketing document. So you can see right here, the estimated classification here is public. And you can see right here the reasoning for this document. So we can go through the bounding boxes of classification here. So you see for this box right here, you can see that this is a classification public, and the reasoning is because of this explanation right here. And so we can go and quickly go through all of the different annotations here. But overall, each and every one of these annotations came out as having a public classification. So really nothing of note here. And same thing with the images. So all of the images in here have been classified as very unlikely to be non-child safe. So let's move on to test case 2. So this right here is a filled-in employment application, and you can see right here, this is classified as highly sensitive. So if you go through, you can see the different classifications for these chunks of text. So as you can see right here, it classified this chunk of text as confidential because of this explanation right here, and with a confidence of 90%. However, overall, this classification for this document was considered highly sensitive because of this block right here, because it has some PII that would likely make this document classified as sensitive. So now I can move on to TC3. And so this one was actually classified as public. And so this is using the base model that we have. And of course, in the actual answer key, this was not classified as public because of the internal nature of this information. So to actually fix this, this kind of classification, we can do is we can go down here and we can actually submit an improved classification chain prompt. What this will do is it will essentially run an LLM to create a new node on our prompt chain that will allow us to be able to classify these documents more accurately. Yeah. So now we can go on to TC4. And you can see right here, this was classified as highly sensitive. So we can move on to the next flag here. You can see that this is confidential because of this reasoning right here. And we can move on to all of these different, we can move on to all of this different annotations right here. So these annotations encode the actual reasoning for this decision. You can see right here. You can also look at the images in this document for their rating. So last but not least, this is our test case 5. Which is categorized very similarly to the last test case. But what's interesting about this is that at the bottom here, there is a picture of a obviously not child-friendly image. So if you go right here, we can see that this image is actually correctly categorized as not child-friendly.
Alright, so how do we actually sort of classify the document, right? So we first start off by running the LLM context generator, which all this does is essentially make a summary for the document as a whole, because as you can probably see, later on in the process, we sort of split the document up into chunks, and the whole purpose behind this is to sort of go into a deeper analysis of the document and really be able to identify which parts of the document are the one that may be causing an issue, right? And the issue with doing this kind of chunking is you do lose some of the context, and what this sort of summary is meant to do is sort of bring back that context in, so the later on prompt tree that we run can really properly classify whether the information is classified, whether it should be public or any other of the classes. So basically, once we have all the different chunks, all these get fed in parallel to Vultr, which each run a prompt tree to sort of get their classification score alongside the explanation for that score and the confidence. Once you sort of get all these different classification scores, you then find which one is the worst one, and you decide that will be the document's classification. Because obviously, if you have highly classified information in a document that has a bunch of public information, the document as a whole will be highly classified due to just having that one piece of highly classified information. Lastly is the human in the loop part. What you are able to do is essentially you can sort of give a prompt for, say, if the model missed a certain thing in the document, maybe it had an API key somewhere in there and you didn't want to leak that, you can sort of just say, hey, don't forget to capture the API key. And our dynamic prompt generation will essentially sort of add this prompt to the prompt tree at the end of it, and will allow the model to sort of learn from the human, from whatever sort of suggestions it gives it.
Okay, so now I'm going to talk about how we put together all of our technologies to make sure that Makoto is fast, efficient, and accurate. As Abraham discussed, we used a custom backend prompt tree in order to generate our inference. Now, this prompt tree was running on a Vultr serverless inference model. Specifically, we were using the lightweight Kimi K2 Instruct model for the low cost and lightweight and quick performance. The Vultr cloud services also provided us with a cloud compute platform, and we use this platform in order to host on the internet our front-end interface, as well as a fast API backend, which the front-end interface used to stream PDFs, as well as all of the inference that we made on the documents. The fast API had several routes for all of the different functions that our platform had. And the first of which was a route to MongoDB Atlas, which is a cloud platform offered by MongoDB. And it served our needs well because they had a grid FS system, which allows us to upload PDFs very easily to the cloud platform. And then they also had a NoSQL database, which was nice and easy to use and integrate with our fast API. The database also stored metadata about the PDFs, including results from optical character recognition and the areas in which the text was found, as well as the results of our inference. In order to generate our optical character recognition, we used the Google Cloud Vision API. And what this did was give us the areas where the text was located, as well as chunks of text, so that we could run our inference on sections of the document and generate classifications for different parts of the document rather than the entire document as a whole. Also, the Cloud Vision API allowed us to do inference on specific images by segmenting images out of the document and running inference on them so that we can determine if any images violate a classification guideline or are not kit-friendly. And then all of this was connected together through our custom fast API, which ultimately linked to our front end, which was hosted in the Vultr compute server.